I guess until somebody tells me to stop or asks that I stop, I'll keep giving you guys these riddles. So I found my mind trap cards. Here you go. As a rule, how long will a so-called 8-day clock run without winding? There you go. Think about that. Alright, example 3. Finding volumes using cross sections. Remember, we've got a base and then we're building a figure on top of the base that's always going to be in the xy plane. This particular one, we have a circle as the base, x squared plus y squared equals 4, and cross sections are perpendicular to the x-axis. The height of these rectangular cross sections is 1, and we'll get to that in a second, but I just want to make sure you're okay with getting these equations for the functions. So it's important that you're able to do this. It's probably the hardest part of this problem is understanding that x squared plus y squared equals 4 is the equation of a circle, but it's not a function, and we need to always express any curves in our xy plane as functions, y as a function of x, or x as a function of y. But in this case, because the cross sections are perpendicular to the x-axis, we need to make sure we solve for y and get y by itself in terms of x. Okay, anyway, that's how we do that. We subtract x squared from both sides, take the square root of both sides, and we get y equals plus or minus the square root of 4 minus x squared. So you can see that, but understanding that the top half of the circle is the positive square root and the bottom half of the circle is the negative square root, you put them together, they don't make a function, but separate, they are each their own function. And so I didn't put the y equals, but I did label the two graphs. Okay, so we have a 3D picture over here, and I also labeled our cross section. Again, the cross sections here are rectangular, and the heights of the rectangles are each 1, but the base would then change as you move from left to right. In fact, as you move from -2, because 2 is the radius of the circle, to +2, and so then again the most critical part here is to be able to express the length of the base of the cross section in terms of x. Okay, and the length of the base would be the top curve, top function, which is radical 4 minus x squared, minus the bottom function, which is negative the square root of 4 minus x squared. So minus minus makes plus. We have 2 of them, so again, that's our bread and butter right there. We've got the length of the base. Okay, so once we get the length of the base, we then transition to the area of the face. Well, the area of the face is length times width, so that becomes really easy because it's just multiplied by 1. Area of the face, just want to be consistent with what I'm writing down. Length times width, which would be, length would be 2 times the square root of 4 minus x squared multiplied by 1. Okay, so we have the area of the face. Now we're ready to find the volume. Okay, so the total volume, let's go back over here. Total volume equals perpendicular to the x-axis, so we're going to be integrating with respect to x, all the way from -2 to +2, the area of the face multiplied by the thickness of that cross section. Area of the face, 2 times the square root of 4 minus x squared, multiplied by the width. So the volume of one disk is right there, and when you type that into your calculator, you should get 12.566, and there you go. That took a little over 4 minutes. Let's try the next one. Example 4, finally we have cross sections that are perpendicular to the y-axis. So let's go ahead and take a look. Perpendicular to the y-axis, that means we need to make sure we get our functions, y equaling x cubed, in terms of well, solve for x in terms of y. So that's that base right there. The base of our square cross section has a length of, and where's my purple? So it has a length of, remember when we're trying to find the length of a horizontal line segment, we always start from the right and we move to the left. So the right hand curve, or the right hand, the right hand curve would be x equals 1, this line, vertical line, minus, so 1 minus that curve right there, the green curve. But common mistake, I want to do this, I want to make sure it's in terms of y. So this curve right here is, again, x equals cube root of y. And so the length of that base is 1 minus cube root of y. That's your bread and butter right there. Have I said that enough? I feel like I've said it about 10 times. So let's go ahead and find the total volume. Total volume. Yeah, I didn't do the other part yet. Let's do that first. Yeah, change my mind. Let's just go ahead and find the limits of integration here. And how do we do that? Well, we know that the curve y equals x cubed, y equals 0. So if we look at this curve right there, so y equals 0 is the x-axis. We know that y equals x cubed goes through the origin. So that point of intersection right there provides us with our lower limit of integration. So that guy right there, and that's when x equals 0. Okay, and oh, sorry, I forgot we're going to be integrating with respect to y. So the bottom of this, it's still 0, but I was looking at it the wrong way. The bottom of this, the lowest y value, and the lowest y coordinate here would be 0. Still would be 0. Okay, but the cross sections are going to be moving from the lowest point, which is 0, to the highest point. Now, when do we get to the highest point? Well, we know that this is 1, but x is 1, but what would y be? Well, y would also be 1. So we have the point 1, 1, and so you really can't go wrong here by integrating from 0 to 1, because you either integrate from 0 to 1 in the x direction, or you integrate from 0 to 1 in the y direction. It'd be interesting to see what we would get as far as what the volume would be if we did integrate, or we did have cross sections that were perpendicular to the x-axis. Okay, but either way, we're going to integrate from 0 to 1, but please understand, that would be the lowest y to the highest y. Okay, they happen to both be the same. So 0 to 1 of the volume of one cross section, but we didn't do that yet. So let's move back over here and let's find the area of the face of the cross section, and the area of the face of the cross section, since the cross section is a square, we already know the dimensions. 1 minus cube root of y squared. Length times width. Length and width are the same. 1 minus cube root of y squared. So there's the area of our face. That's what we need. No, I'm not going to say it's our bread and butter. I guess I just did. 1 minus cube root of y to the second power. That's the area of the face. Don't forget, the thickness of that cross section is dy. Again, we are. I just write that in. We're integrating with respect to y. You really need to be telling yourself these things over and over again. Okay, you've got to remind yourself, okay, integrating with respect to y, we're going from bottom to top. That little change in y is why we have y, because it's going up and it's going from bottom to top. It's a little bit of a vertical distance. Doesn't look vertical here, but you know, the y is up there, the x is down here. So there you go. It's still less than my 10-minute mark, and we should get. Now this is another one that I thought, man, it just seems like it'd be more, but I got 0.099999, and that ends up to be just 0.1. Kind of a boring answer, but if anyone is able to, I can't find any mistakes. I've done this twice now, and I get the same answer each time. So If you find a mistake, please let me know, and I will change it, but you'll also get extra credit. I don't think it's a mistake. It just seems like it's off a little bit. And what was that last riddle that I shared with you? If the clock isn't wound, it won't run at all. How long will an 8-day clock run without winding? It won't run at all. There you go. Are they getting better or worse?